Let us look at reciprocal polynomial equations. An equation is called a reciprocal equation if replacing x with 1 by x and multiplying throughout by the highest power of x present in the equation reproduces the original equation, either unchanged or with every coefficient changing sign. So let's see what this means. We have this equation, polynomial equation, f sub n of x equal to this polynomial equal to 0. Replacing x with 1 by x gives f sub n of 1 by x is equal to a sub naught plus a1 by x plus a2 by x square plus dot 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 plus a sub n by x to the power of n equal to 0. So basically what are we doing here? We are applying the reciprocal transformation. Multiplying throughout by x to the power of n gives us x to the power of n times f sub n of 1 by x equal to a sub naught x to the power of n plus a sub 1 times x to the power of n minus 1 plus a sub 2 times x to the power of n minus 2 plus dot 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 plus a sub n equal to 0. Now, if the transformed equation is the same as the original except for the sign changing, then the equation is called a reciprocal equation. So given an equation, if we apply the reciprocal transformation and we get back the original equation with the signs reversed or not reversed, then it is called a reciprocal equation. Let's look at an example. We have x to the power of 4 plus 3x cubed plus 5x square plus 3x plus 1 equal to 0. Replace x with 1 by x. Apply the reciprocal transformation. Multiply throughout by x to the power of 4. Simplify. And we get 1 plus 3x plus 5x square plus 3x cubed plus x to the power of 4 equal to 0, which is exactly the same as the original equation. So the equation remains the same except the order of the terms or the order in which they are written is reversed. In other words, the coefficients are palindromic or symmetric. So one way of immediately recognizing such an equation is that first term coefficient, last term coefficient is equal. Second and the second last is same, and so on. This means the coefficients read the same from both ends. So if we read it from this side, 1, 3, 5, 3, 1. From this side, if we read it, 1, 3, 5, 3, 1. Therefore, if alpha is a root, remember alpha can't be equal to 0, then it doesn't remain a nth degree polynomial. Then 1 by alpha is also a root. Okay, now that we have understood what are reciprocal polynomial equations, let's look at types of reciprocal equations. Type 1 or class 1, when we apply the reciprocal transformation to a function and it gives back the original exactly, then it is a type 1 reciprocal equation. A class 1 reciprocal equation is one where a sub k or coefficient of the kth term is equal to the coefficient of n minus kth term. That is, coefficients equidistant from the beginning and the end are equal. Now, if there is an odd number of terms, the middle coefficient is paired with itself. So, for example, if you look at this, 6, 6, 25, 25, 31, 31, 12. And 12 is paired with itself. If there is an even number of terms, every coefficient forms a pair with another coefficient. So here, 6, 6, 25, 25, 31, 31. Now let's come to type 2. Now, here what happens when we apply the reciprocal transformation, we get the negative of the original equation. A reciprocal equation of class 2 is one where a sub k is equal to minus a sub n minus k. That is, coefficients equidistant from the beginning and end are equal in magnitude but opposite in sign. So again, an example: x to the power of 5 minus 5x to the power of 4 plus 6x cubed minus 6x squared plus 5x minus 1 equal to 0. Again, let's apply the reciprocal transformation. We get this. So here, if you notice, let's compare this with this. So coefficient of x to the power of 5 is 1 here. Here it is minus 1. Here it is minus 5. Here it is plus 5. Plus 6, minus 6. Minus 6, plus 6. Plus 5, minus 5. Minus 1, 1. Which is the negative of the original equation. If there is an odd number of terms, the middle coefficient is paired with itself. Now let us look at properties of reciprocal equations. If alpha is a root, then 1 by alpha is also a root, which means 0 cannot be a root. Why? Because then 1 by 0 will also be a root, which is undefined. So 0 cannot be a root. In a reciprocal equation of odd degree, roots occur in reciprocal pairs. So which means, since the total number of roots is odd, one root must be its own reciprocal. Only numbers that are equal to their own reciprocals are plus 1 and minus 1. So based on this, there are certain additional inferences we can draw. In an type 1 equation, minus 1 is always a root, which implies x plus 1 is a factor. In an odd degree type 2 equation, 1 is always a root, which implies x minus 1 is a factor. Now, in an even degree type 1 equation, no factor is guaranteed. In an even degree type 2 equation, x equal to plus or minus 1 are two of the roots, which implies x square minus 1 is a factor. So based on this, if you can recognize a given equation, polynomial equation, as a reciprocal equation, immediately you will know at least one or two factors. So reciprocal equations remain unchanged under the reciprocal transformation. Such equations are said to be invariant under the transformation. Because remember, even if it is negative of the original equation, we can multiply throughout by minus 1 and get back the original equation. So that was reciprocal polynomial equations. That's it for now.